Hello guys. Welcome to Catolabs. This is your boy, Bukos Ndlangamandla Kumalo. What you are seeing on the screen there it is a soil erosion risk map, which I created or estimated using the revised universal soil loss equation within Google Earth Engine. I also used QGIS. But basically this is based on Google Earth Engine. So this revised universal soil loss equation, in short, which is called a RUSLE model, uses 5 factors to estimate soil erosion. So these 5 factors include rainfall erosivity factor, the soil erodibility factor, the slope length, slope steepness factor, the vegetation cover management factor, and the practice management factor, conservation and practice management factor. So to estimate these input factors, there is need, especially if you are working on a large territory, there is need for a combination of large data sets that are covering large areas. So I believe that Google Earth Engine offers access to a variety of data sets that you can utilize for a model. So that's why I want to create a series of videos, tutorials that I'm going to share with you on how you can run a RUSLE model within Google Earth Engine, especially using GMap, which is a Google Earth Engine Python API. So I will show you how I estimated all these factors using GMap, and then I'll show you how I combine them using again GMap. But I will also further show you how to visualize the data, how to reclassify it, how to calculate areas for each class, how to calculate mean erosion rates per slope classes, how to calculate mean erosion rates per land cover types, and so forth. So you are going to learn a lot of things, from how to access data on rainfall, on soil types, how to process it, data on land cover. I would have also shown you how to do land use land cover classification, which is important. But we also have open data sets like ESA 10 meters world cover data set. You can also use those data sets and assign specific values to those data sets that represent the risk of erosion. So there are a lot of data sets that you can get on Google Earth Engine, which you can utilize for your model. This saves you a lot of space because most of the data sets will be saved on the cloud. This saves you a lot of time because you know that Google Earth Engine can process a large quantity of data, large quantity of algorithms within a few seconds and so forth. So this saves you time, it saves you the space and a lot of things. So if you are interested in working on soil erosion, and because soil erosion is an important factor in terms of sustainable management of our land and water resources. Remember, you cannot, it's difficult to manage water resources, water reservoirs, without looking at the aspect of siltation. So in order to address siltation, we have to look at the sources of the sediment that is deposited in rivers. So in order to do that, we need to model soil erosion risk. Remember that we have traditional methods which are more accurate, but they are so difficult to apply in large catchments. You end up generalizing for some areas where they are for the ungauged stations. So it is important to utilize the power of GIS, the power of cloud computing, the power of Google Earth Engine, the power of technology to do these soil erosion risk estimates. So basically this model will look at the topography of an area, the rainfall amount received, the soil types, the vegetation cover or land use types of that pixel, and then give you an estimate of annual rate of soil erosion in tons per hectare per year. So if you are really interested in learning about how to use Google Earth Engine in soil erosion studies, please subscribe to this channel. It's gonna be lit. Please click the notification button. Please share to some of the guys. Maybe I know you might be a master's student, a bachelor student looking for a topic, so you can learn one or two things from what I'm gonna teach you. So, but basically, I'm not. I'm a starter in terms of programming, in terms of using Python. So I'm a starter in terms of using Python, but my coding skills, I'm able to code and be able to achieve a certain objective. But you'll find that I'm not privy to some of the standards that I use, like for instance, using functions and so forth. So my code usually is very long, but it's able to achieve the objectives that I intend to achieve. So you're gonna learn a few things, but I hope that at the end of the day, you'll be able to give me recommendations to say, you could have done this thing in a different way. You could have shortened this code by creating a function like this one, which will automatically compute all the algorithms that are involved. So I'm hoping to teach, but also at the same time to learn how I can improve my coding skills, especially regarding to this specific task. This was my master's model, but when I was doing my master's project, I involved Google Earth Engine to calculate a few things like land cover, land use classification, precipitation data. The other factors, I calculated them using ArcGIS and ArcMap and QGIS. So, but even for this case, I tried to calculate a topographic figure. So even in this case, I tried to estimate the slope steepness, slope length factor, which is the topographic factor, using Google Earth Engine. But the code was very difficult for me, so I ended up estimating it easily using QGIS, because it's fast to use QGIS. There's a tool that has already been developed, which you can use to estimate the LS factor. So what we're gonna do, we're gonna use also QGIS to create specifically the LS factor, and then input it into Google Earth Engine as an asset, and then take that asset to Python, to Jupyter Notebook, and use the LS factor that has already been created using QGIS. So that's it, guys. I'm hoping that you're gonna learn a lot of things. So if you're interested, please subscribe to my channel. I'll be releasing these videos as of tomorrow. You can also find some of the code. I'm going to share it on my GitHub. The link is gonna be provided below, and then I'm also going to share it on my website. So if you're interested to try and modify the code and recommend and share and also develop it further, you can do so. You can access it on these aforementioned links. Thank you so much, guys, for being with me. Hope you're gonna be interested in this. See you then. Let's do this. Paka. Das vidania. Lisale kahle. So bonani. Bye.